Hey guys, what we're going to do is I'm just going to go through a few of the examples from the lesson on how to simplify rational expressions, just in case you need a reminder or in case you weren't here. Okay, so a rational expression is anything that can be written as a fraction, and in these we've got a monomial over binomial, and the idea is to simplify. It also says to state the excluded values, and we'll talk about that in a second. So the first step you always want to do is factor. So if you can, look for things that you can factor, numerator and denominator, okay? So in the numerator, I've just got to leave 9x. There's nothing I can do to that. But in the denominator, I notice that 15 and 12 have a common factor of 3. So I'm going to factor out a 3, and then they both have at least one x, so I'm going to factor out an x as well. When I factor a 3 out of 15, I'm left with a 5. Think of it as dividing. And then I factor 1x out of x squared, I'm left with another x. Okay? Minus 12 divided by 3 is 4, and then I factored out the x, so it's gone. Okay, so before I simplify, this is the expression that we've got. The idea now, or to make sure that I get it right, I'm going to go ahead as soon as I factor and look at the denominator and try to figure out the excluded values. Now, the point of the reason for the excluded values is that when you deal with functions that are rational, you have to consider what's happening in the denominator, because one thing you cannot do is divide by 0, okay? So I have to think about what are the things that make the denominator equal 0. Well, it's 3 times x, so 3 times what gives me 0? 0. So x cannot equal 0, because if I plug in 0, I get undefined. And then for this one, when does 5x minus 4 equal 0? Well, 5x minus 4 equals 0. When, just solve for x, I get 5x equals 4, or when x equals 4/5. So you add 4 and divide by 5. Okay? So the excluded values are 0 and 4/5. Now, when I actually simplify the expression, 0 is no longer going to be an issue. Because you might notice that, well, 9 divided by 3 is 3 over 1. The x's divide by each other, and x divided by x is just 1. So really, my final answer is 3 over 5x minus 4 times 1, which we don't have to write. Okay? So in this one, it looks like only 4/5 is an issue, but actually 0 is as well, because we're talking about the original expression. So for the original expression, we're supposed to state the excluded values, 0 and 4/5, and simplify it down to this expression right here. Okay? Okay, let's go and do that one. The numerator, I can't do anything with it, so I do x plus 5. And then the denominator, I factor out a 5, because they both have a 5 and 5 and 25. So I'm left with x plus 25 divided by 5 is 5. Okay? Excluded values, look at the denominator. When does the denominator equal 0? There's not an x out here, so I don't have to worry about that. So what value of x will give me 0? Negative 5 plus 5 will give me 0. So x cannot equal negative 5. Okay? Now, as far as simplifying, this is multiplication. So what I can do is I can say this divided by this is 1 over 1. I don't have to write that one down, though. So I've got 1 over 5 is the simplified expression of that, with the exception of negative 5. Okay? So if you actually graphed this, not that we're there yet, but if you graphed it, you would get a horizontal line at 1/5, except for at negative 5, where it would not be defined. Okay? On this one, again, I said the first thing you want to do is factor. Now, I kind of didn't finish my numbering, but 2 and 3 are kind of interchangeable. You can either find the excluded and then simplify, or you can simplify and find the excluded. The only issue I have with simplifying first and then finding the excluded is that you might forget to think about the original factored form, and you need to whenever you find the excluded values. Okay, so I want to factor. This is a quadratic with a quadratic linear and constant, which means I want to try and factor as in the factors of that add up to. So I'm looking for the factors of negative 12 that add up to negative 1, 1 and 12, 2 and 6, 3 and 4. 3 and 4 have a difference of 1, and I need a negative 1, so negative 4. Positive times a negative is negative. So I've got x plus 3 and x minus 4 for the numerator. Okay? For the denominator, I don't have 3 terms, so the most I can do is a GCF, a greatest common factor. A 4 is not in either of them, but an x is, so I'll factor out an x. And I'm left with a 4 minus 1x. Okay. Now, excluded values. I look at the denominator. What makes this 0? Well, a 0 right there would make everything 0. So x cannot equal 0. And then 4 minus what gives me 0? 4 minus 4 gives me 0. So, as far as excluded values, it's 0 and 4. Now, when I look at this, okay, this right here, x minus 4, and this right here, 4 minus x, are exactly opposite. We've got a positive x and a negative x, a negative 4 and a positive 4, which means that technically, if I manipulate it a little bit, I can simplify this, or I can simplify these 2 expressions together. So what I want to do is I want to think about factoring out not only the x here, but a negative x. So if I had started off, let's factor out a negative x. Well, 4 divided by a negative 1, if you will, is a negative 4. The x is gone because I factored it out. If I divide a negative x squared by a negative x, I'm going to the positive x. Okay? So you don't have to go back and think about doing that all over again. All you got to do is say, okay, either from doing it in the top or doing it in the bottom, I'm going to factor a negative out of this expression, leave me with a negative and a positive. Okay? Now I have a negative 4, positive x, which means these do simplify now. Okay, and I didn't mean like x simplifies with x and 4 simplifies with 4. It's more like this simplifies with that, the whole thing. Okay, so here's what I've got. X plus 3 divided by negative x, but we don't leave negatives in the denominator. So we float it to the numerator. And you can do this a couple different ways. You can either say, I'm going to float the negative to the front and say negative the fraction. Or you can say, well, I'm dividing each term by a negative 1. So I could say negative x minus 3 over a positive x. So either one works. That's not along with the excluded values. Okay. On this one, we've got to factor. Okay. So I noticed that this is a quadratic form, but it's got a cubic function, but then all 3 of these have an x, which means I can factor an x out. So I'm left with x squared minus 2x minus 8. Okay? And I'll go ahead and we'll just continue with the numerator. X, and then now this is the quadratic form, quadratic linear constant, which means I can factor the factors of negative 8 that add up to negative 2. 1 and 8, 2 and 4. 2 and 4, if I have minus 4, then I get a negative 2 when I add them. So I've got x plus 2 and x minus 4. Alright, so for denominator, I'm going to go ahead and skip over to here. This is a quadratic linear constant. What are the factors of 8 that add up to negative 6? 1 and 8, 2 and 4. Well, 2 plus 4 is 6, but negative 2 and negative 4 is negative 6, and the negative times a negative is a positive. It's important to check those to make sure, because there are some situations where there's two options depending on the positive or the negative of this number right here. So x minus 2 and x minus 4. Okay, I'm going to go ahead and state the excluded values. Looking at the denominator, I know that x cannot equal a positive 2 because 2 minus 2 is 0, or a positive 4. Okay? As far as simplifying goes, these two are exactly the same, so they divide out to 1. And then I've got these 3 left over. So the question is, can I factor out a negative and make these cancel out? Well, if you factor out a negative, that makes that a negative x and a positive 2, which is not what this is. So you can only factor out a negative if they're exactly opposite, meaning if that's positive, that's negative, but if that's positive, that has to be negative as well. Or if that's negative, that can be positive. So there's nothing else I can do. X times x plus 2 divided by x minus 2. And there you go. Okay. Okay, so what if I have something like this? Simplify and state the excluded values. So Factor. Okay, I noticed that all three of these numbers in the numerator are even. So I'm going to factor out a 2. And I'm left with a 5, an 8, and a 3. Okay. And so then, let's go ahead and do that with the denominator as well. Do you need something? Oh, you did. Check again. Alright, in the denominator, they've got a 4, 4, and 8, so I'm going to factor out a 4, and I'm left with p squared minus 1p minus 2. So it's like dividing out the 4. Okay, now I need to factor again. So, in this one right here, I've got 5 times 3. And so I've got 5 times 3 is 15. Anytime you have a lead coefficient greater than 1, you have to multiply. Factors of 15 that add up to 8 are 5 and 3. So we do p plus 5, p plus 3. But because we had to multiply, we have to remember to divide by the 5. Okay, so it's going to have 2 times p plus 5 divided by 5. 5 divided by 5 is 1, so p plus 1. P plus 3/5, that doesn't simplify, so I'm going to move the 5 up and say 5p plus 3. Okay, the denominator, this is a leading coefficient of 1, so we're looking for the factors of negative 2 that add up to negative 1. The only factors of 2 are 1 and 2, and in order to get a negative 1, I've got to have a negative 2. So p plus 1 and p minus 2. Okay, so there's the fully factored form, and once I do that, I want to state the excluded values. Looking at the denominator, p cannot equal a negative 1, because negative 1 plus 1 is 0, and p cannot equal a positive 2. Okay? The only other thing is simplifying, and I noticed that they both have a p plus 1, and nothing else simplifies. So 2 times 5p plus 3 divided by p minus 2. Okay. I just want to talk about something right, well, I might as well do it. I'll just go ahead and have it on there. Okay, factoring. The numerator only has 2 terms, but I noticed that 6 goes into 24, so I'm going to go ahead and factor out a 6. And I'm left with x squared minus 4. 24 divided by 6 is 4. Okay? 4, 10, and 4 are all even, so I'm going to factor out a 2, because 4 doesn't go into 10. And I'm left with 2x squared minus 5x plus 2, divide everything by 2. Okay, now, just as a reminder, the numerator is x squared minus 4. You have to remember that that is called a difference of perfect squares. This is technically x squared minus 2 squared. Well, a lot of people were saying, and then when I asked you, how do you factor that? You think, well, put a 0x in there, and that kind of helps. Yeah. What are the factors of negative 4 that add up to 0? 1 positive 2 and 1 negative 2. Okay? So, x plus 2, x minus 2. But if you just remember a difference of perfect squares, if I say x squared minus 4, x plus 2, x minus 2. If I say x squared minus 25, x plus 5, x minus 5. Okay? Alright. Leading coefficient is different from 1, so I've got to multiply. 2 times 2 is 4, and I want the factors of 4 that add up to the middle term, negative 5. So I've got 1 and 4 that add up to 5. If they're both negative, you multiply to get a positive and add to get a negative. So that's what I want. X minus 1, x minus 4. But because I multiplied, I have to remember to divide. So I've got the 2 in the front, and then I've got this factor. 1/2 does not simplify, so I bring the 2 up. 2x minus 1. 4 divided by 2 does simplify, and so I've got x minus 2. Alright. Excluded values. So when does the denominator equal 0? There's not an x, so I don't have to worry about that. When does 2x minus 1 equal 0? Well, that came from this right here. So x minus 1/2 equals 0 when x equals positive 1/2. So x cannot equal positive 1/2. And then 2 minus 2 gives me 0, so 2. Last step, simplify. That with that simplifies, and I'm left with, and 6 divided by 2 is 3. So I've got 3 times x plus 2 divided by 2x minus 1. is a simplified form. Okay. Maybe that should up a little bit.